Welcome to The Explainer. Today, we're targeting a massive, frankly, sneaky hidden cost lurking inside your infrastructure: bloated Docker containers. Look, if you're developing modern apps, you're relying on Docker, right? It's how we package and ship code. But what happens when that package gets unbelievably heavy, slow, and just downright expensive to move around? Well, today, we're going to literally eliminate that bloat. We're looking at a structured, three-step approach taken directly from the latest engineering best practices to help you engineer smaller, lightning-fast builds. Let's get into it.
Seriously, consider this for a second. Why on earth would you ship a 1.5 gigabyte container for a tiny web app that only needs, a few megabytes to actually run? It's completely absurd, but honestly, it happens all the time. It's kind of like renting a massive cargo plane just to deliver a single pizza. You're dragging an incredible amount of unnecessary weight right into your production deployments. And all that extra baggage, it slows down absolutely everything, from your continuous integration pipelines to your cold start times. Plus, it just drains your resources.
So what exactly is taking up all that space? Let's unpack the secret baggage hiding inside standard containers. See, when you use a traditional single-stage Docker file, you aren't just packaging your app. You're inadvertently bringing along the whole shebang, the entire development environment. We're talking testing frameworks, package caches, system tools, compilers, and just a mountain of dev dependencies that your application absolutely does not need to actually run. And not only does this bloat your file size and slow down CI/CD, but it massively expands your attack surface. Literally every unnecessary tool is a potential security vulnerability. No thanks. So, to fix this, we're going to implement 3 steps. Number 1, establishing a context firewall. 2, optimizing layers for caching, and 3, unlocking the power of multi-stage builds.
All right, let's dive right into step 1, the context firewall.
So before Docker even starts executing your Dockerfile instructions, it sends your build context, which is essentially your whole project directory, straight to the Docker daemon. Think about that. If you send your entire project folder over, you've pretty much lost the speed battle before the build even kicks off. A massive context slows down every single build, even the cached ones. And this is exactly where the .dockerignore file comes to the rescue. It's a configuration file that explicitly blocks unnecessary files and directories from being part of that initial transfer.
The crucial thing here is knowing exactly what to block. You've got to exclude heavy, bloated folders like your node_modules, your .git history, temporary files, docs, and test files. But even more importantly, you absolutely must exclude sensitive files like your .env configuration. You really don't want to accidentally bake your secret keys into your images, right? Keeping this context lean guarantees a blazing fast transfer to the Docker daemon, setting you up for a perfectly optimized build.
Moving right along to our second strategy, let's talk about optimizing layers for caching.
Okay, so Docker images are built sequentially, instruction by instruction, and every single command in your Docker file creates a new layer. Now, Docker is smart. It caches these layers to speed up your future builds. But here is the fundamental, absolute golden rule of Docker caching. If a layer changes, every subsequent layer after it must be rebuilt from scratch. It's like a domino effect. Because of that, the exact order of instructions in your Docker file completely dictates your cache efficiency.
So, to get the absolute maximum cache hits, you need to order your instructions from least frequently changed down to most frequently changed. First, declare your base image. Second, and honestly, this is the magic step, you only copy your package manifests like package.json or go.mod. Third, run your install command. Then, and only after your dependencies are fully installed, do you finally copy over your actual source code. Why do we do it this way? Well, your source code changes all the time, right? But your dependencies, they rarely change. By separating the installation from the source code, you're literally hacking the cache. Your heavy dependency downloads stay happily cached, so changing a single line of app code only triggers a super fast rebuild of that final layer.
Which brings us to step 3, the absolute paradigm shift for container architecture: multi-stage builds. Just look at the night and day difference here. Traditional single-stage builds include all your compilers, source code, dev tools, the whole 9 yards. They frequently clock in well over a gigabyte, take forever to pull, and leave you totally vulnerable. But the multi-stage approach? A total game changer. The final image contains just the compiled binary or the exact files needed for runtime. It's stripped down, often hovering around just 20 megabytes, and it is lightning fast.
So how exactly do we pull this off? It's simple. Multiple from statements. Every time you use one, you start a brand new stage. You use your heavy, fully loaded image to compile the app in stage 1. Then, you start entirely fresh with a pristine, minimal image, something like Alpine or even Scratch.
Finally, you just pluck the compiled artifacts from stage 1 and drop them into stage 2. All those heavy, clunky compilers, they just get left behind in the trash.
Really, it all boils down to one golden rule. Build heavy, ship light. It's totally fine to let your development environment be as complex as it needs to be, but you've got to keep your production environment absolutely minimal. If you take away anything today, make it this mantra. It's the core of modern container optimization.
Now, what happens when you actually combine the context firewall, intelligent layer caching, and multi-stage builds? Well, the data on size and speed speaks for itself.
Seriously, the payoff here is dramatic. Check out this return on investment. A standard Node.js application drops from 950 megabytes down to 180 megabytes. That's an 81% reduction. But wait, it gets crazier with compiled languages and static assets. A Go API plummets from 850 megabytes down to just 15. And a React front end, it shrinks from 1.2 gigabytes to a microscopic 25 megabytes. We're talking about a staggering 98% reduction in image size. No way you can ignore those numbers.
And hey, this reduction isn't just some vanity metric. It translates directly to your bottom line. By dropping all that dead weight from your infrastructure, organizations are reporting an 80% or greater reduction in container registry storage costs. You're literally saving money simply by not paying to store files you never even needed in the first place.
Plus, the benefits totally extend to operational performance. When your images are 90% smaller, obviously they're going to move way faster over the network. The data actually shows container pull times improving by 75 to 85%, and that directly translates to lightning-fast deployments, incredibly responsive auto-scaling when your traffic spikes, and way quicker cold starts for serverless functions. Shipping Light just makes your entire architecture profoundly more agile.
So as we wrap up this explainer, I want to leave you with a question to chew on. What unnecessary baggage is hiding in your production images right now? Seriously, go take a look at your Docker files today. Add that .docker ignore file, reorder your instructions to hack the cache, and definitely implement multi-stage builds. It's time to strip out the bloat and start shipping light. Catch you next time.